All right, you're welcome back once again. Um, we have a question here. Remember, we are still in circle theorems. We have looked at several examples already, and we are here to solve more problems in circle theorems. We started by doing the theorems one after the other. We have done a lot of them behind here, and right now we are now applying them in solving problems. Okay, I implore you to look at those theorems because they will help you to understand the application that we are doing now. All right, look at this question and what is it actually asking us to do? This question is asking us to calculate the unknown angles. Of course, here is unknown, here is unknown, here is unknown. And then, how are we going to be able to assess, okay, the question and handle the problems? So there is always an access point, like I tell my students that for every mathematical question, just check out for the access point, the point through which you can be able to assess that question and resolve it. So solution, I've already seen a point through which I can enter. Now consider this, considering a triangle QOR. Okay, this triangle, okay, QOR. You know that this this angle here is equals to this angle here. What am I trying to say? R Q O is equals to Q R O. How? Base angles of isosceles triangles are equal. So that is our access point. So if that is the case, we can now go there and say, that means that by implication, here is also 36 degrees because this triangle is isosceles. This is RO and this is QO. Both of them are red eye. Okay, they join the center and the circumference. So we can start from there. So we can say that 86 degrees plus 36 degrees plus n equals to 180 degrees. Sum of angles in a triangle. So we can deploy that, and then we have 72 degrees plus n equals to 180 degrees. That means n is equals to 180 degrees minus 72 degrees. By implication, n is equals to 108 degrees. N is 108 degrees. Okay, so that is this one. Now how do we enter here? So we are now going to also look at another theorem that can help us to do that, and that theorem is a theorem that says the angle at the center of the circle is twice the angle at the circumference. That is to say that QOR is equals to 2 times QMR. That is QOR is 2 times QMR, not this one, no, this one here. Okay, so it then means that n is equals to 2 times m, and this is 108 degrees equals to 2m. So dividing both sides by 2, you can now realize that 108 degrees over 2 is equals to 2m over 2. It then means m is equals to 54 degrees. M is 54 degrees. Now, if m is 54 degrees, we want to find k. Now, if you consider this triangle PQM, like this triangle, PQM, this triangle there. Okay, if you consider this triangle, you realize that m is equals to 20 plus k. If I say so, you wonder why was it so? Yes, it's true because external, let me back it up with the theorem that supports that exterior angle of a triangle equals sum of two opposite interior angle. Okay, so if you understand that theorem, which in the previous classes I have been able to show that, you understand that this holds. Okay, so it then means m, which is what is m now? We've been able to get that 54 degrees, 54 degrees is equals to 20 plus 20 plus k. So I hope I'm not too fast. So we have 54 degrees minus 20 degrees equals to k. They mean that k is equals to, what's the difference here? 34 degrees. So k is equals to what? 34 degrees. K is equals to what? 34 degrees. You see, within 5 minutes or thereabout, I've been able to show us a way to handle a problem like this that say find the unknown angles in this question or in this diagram. All right, there are still a lot of them that we are still going to be looking at. All I'm telling you that if this video has been of help to you, like it and then share it to someone else and then click on the subscription button, because we still have a lot that is coming up. And when you click on the subscription button, when you subscribe to the channel, you'll be able to access the previous classes. We had many of them. We have done a lot of topics. We are heading to 150 videos already, classes already online. So we are progressing, and we are trusting God that if you are there to support us, we will do more. Thank you so much for being there.